This week we are looking at hominids, specifically focusing on the characteristics of pre-australopithecines and australopithecines. Question: what are the two traits that define hominids? A hominid refers to humans and human ancestors. In particular, hominids are a group of primates with two important features: bipedalism and non-honing chewing. While modern humans possess other unique traits such as spoken language, advanced cognition, and complex culture, not all human ancestors possess these. Bipedalism involves a variety of changes to the skeleton, including a shifting of the foramen magnum on the back of the skull in quadrupeds to the front of the skull. In addition, bipeds have longer legs and feet with two arches. The pelvis of bipeds much shorter from the front to the back than in quadrupeds, and the big toe is no longer opposable. Non-honing chewing is characterized by a number of changes in the dentition. First, the canines are smaller and non-projecting, and much more blunt. In addition, there's no longer a stemma between the canine and the lateral incisor. Non-honing chewing also changes the pattern of wear on the teeth. Instead of wear on the back of the canine, hominids show wear on the tips of the canine and the third premolars. Lastly, the cusps of the third premolars are equal in size. Question: what are the three main hypotheses regarding the origins of hominids? The first hypothesis is known as Darwin's hunting hypothesis, which suggests that hominids were bipedal because it freed their hands to carry weapons. Darwin believed that hominids' greater intelligence, due to larger brains, enabled them to make use of tools. However, it's now known that bipedalism occurred long before brain size increase and the first stone tools. The second hypothesis is the patchy forest hypothesis, originally developed by Peter Rodman and Henry McHenry. It suggests that bipedalism arose because it was more energy efficient in certain environments, especially those with few trees. When the forest became patchier and food more dispersed, hominids more effectively used their energy by walking upright and could carry the collected food with their now freed hands. The third hypothesis is the provisioning hypothesis by Owen Lovejoy. This hypothesis suggests that bipedalism arose due to monogamous males provisioning females with food and protection from potential predators. By provisioning females with food, the females would potentially be able to care for more than one dependent offspring at a time, reducing the time between births. Males would need to have freed their hands in order to carry food for the females, and thus bipedalism arose. Question: what are some of the benefits and costs of bipedalism? Bipedalism has a number of advantages, including being able to see farther, carry food than our children, and run long distances. Eventually, freed hands would enable hominids to create and use tools. However, this feature would require increased brain size, which occurred millions of years after bipedalism arose. Bipedalism also has a number of disadvantages, such as greater exposure to potential predators. While bipeds can see further, they can also be seen more easily. Potential back injuries, including slipped discs and arthritis, are another disadvantage, as walking upright, lifting heavy objects, and carrying heavy items put substantial strain on the lower back. Varicose veins may also result from bipedalism, as the circulatory system has to move blood from the legs to the heart. In some cases, the valves in the veins in the legs break down and blood pools, causing the veins to bulge. Finally, if an injury occurs in one foot or leg, the individual is unable to move. For early hominids without cultural adaptation such as crutches, this would have drastically affected their ability to survive. Question: who are the pre-australopithecines? Pre-australopithecines are the oldest hominids. Most often the remains of the pre-australopithecine species are fragmentary and possess both ape-like and human-like traits. These species were likely bipeds, one of the main features of hominins. The oldest species is Sahelanthropus chilensis, a fossil found in Central Africa, dating between 7 and 6 million years ago. It had a small brain, roughly the size of modern apes. Orion tungstenensis was discovered in East Africa and dates to 6 million years ago. It had curved phalanges, which suggests that while bipedal, Orion continued to use the trees. Ardipithecus cadava and Ardipithecus ramidus were found in East Africa and date between 5.8 to 4.4 million years ago. These fossils also had curved phalanges, indicating continued use of the trees. All of the pre-australopithecus were found in wooded environments, were diverse, and were morphologically primitive. Question: who are the australopithecines? The australopithecines are a more recent group of hominids than the pre-australopithecines. There are at least 7 distinct species represented by hundreds of fossil remains. The fossils have been found in both East Africa and South Africa and are clearly bipedal with non-honing chewing. They also have a range of variation in size and robusticity. The oldest australopithecine is Australopithecus amurensis, ancestor to Australopithecus afarensis. Australopithecus afarensis was ancestral to several other species, including Australopithecus africanus from South Africa and Australopithecus garhi, who made and used the first stone tools. Australopithecus planteops existed at the same time as Australopithecus afarensis, but had much flatter face and derived features. A special group of australopithecines, the robust australopithecines, possessed a number of robust cranial and dental traits, such as a sagittal crest and large posterior teeth. The robust australopithecines include Australopithecus anthropopithecus, Australopithecus boisei, Australopithecus robustus, a South African descendant of Australopithecus africanus.